Okay, so we're going to convert minus 0.125 base 10 to the IEEE 32-bit format. That's single precision. Okay, so starting off with the sign bit. Now we have a negative, so therefore the sign bit is set to 1. Then we take our decimal number, we're going to convert it into binary. So we have the decimal, the whole number part, and the fraction part. So the whole number is 0 and the fraction is 0.125, and I need to convert each of these into binary. So here the binary conversion of 0 is 0. So let's now deal with the 0.125. So 0.125 multiplied by this by 2, that gives you 0.25. 0.25 times 2. Remember, each time we subtract the whole number part, so that's 0, and then the result we copy here. So 0.25 times 2 gives me 0.5 minus the whole number. Remember, the whole number is this value, so I just copy the whole number bit there. And then subtract, then copy the 0.5, multiply this by 2, that gives me 1.0, subtract 1, so the whole number part there which I copy, and so the result there is 0, and so I stop. The number, I copy this from the top and run down. So in our case now we have the 0, decimal place, and then I copy the fraction which is 001 after the decimal place. So that's 001 base 2. Okay, so the next thing we need to do is normalize. So we have 0.001 and I need to normalize such that the value is in the form of 1 point and the remaining bits. So we have 0.001. So I need to shift the decimal place to the right. So let's do that. So we shift it by 1, 2, 3 places to the right. So I can rewrite my number as 1 point, and I can put as many zeros as I like, and then we have 2 to the power of minus 3. So just a note with the sign in terms of the exponent, we have minus 3. So if I shift to the right, the sign of the exponent is negative, and if I shift to the left, the sign of the exponent is positive, and in our case we have minus 3. So my exponent is equal to minus 3. Now I need to normalize, so I'm going to add the value of 127. Next slide. So my exponent is equal to minus 3, and now I want to normalize, so I'm going to add 127. So minus 3 plus 127, and that gives me 125 base 10, and then I need to convert this to binary. So we have 125 divided by 2, that gives me 62, remainder 1. 62 divided by 2, that's 31, remainder 0. 31 divided by 2 gives me 15, remainder 1. 15 divided by 2 gives me 7, remainder 1. 7 divided by 2 gives me 3, remainder 1. 3 divided by 2 gives me 1, remainder 1. 1 divided by 2 gives me 0, remainder 1. And remember, we copy the value starting from this position and going up in this direction. So my exponent, if I draw this out, remember I need 8 bits. We have, so starting from here, we have 1, 1, 1, 1, 1. That's 1, 2, 3, 4, 5 ones, a 0 and a 1. So if I count the number of bits, I have 1, 2, 3, 4, 5, 6, 7 bits. So I need to pad. So I add a 0. And we always add the 0 on the left hand side. So let me redraw. That's 1, 1, 1, 1, 1, 0, 1. That's 1, 2, 3, 4, 5, 6, 7. And let's add the padded bit. So we have an 8-bit representation, which is the number of bits for the exponent. The next and the final bit that we want to do is the mantessa, or the fraction part, which is 23 bits. But let's summarize what we have so far. So we have the sign, which is set to 1. We have the exponent, which is 0 followed by 1, 2, 3, 4, 5 ones, then 0, 1. And now we want the fraction, and to deal with the fraction part, and this is 23 bits in length. Okay, so we go back to our original number that we normalized. That was 1 point, and then we had a series of zeros, and we can have an infinite number of these. That would change the number. Okay, so for the fraction part, we write down the number that we converted into binary. We ignore the 1, and we copy the first 32 bits of the fraction. In our case, that's 32 zeros. So it's 23 zeros. Let me just correct that. The first 23 bits. So 23 bits here. And so we have 23 zeros. So in summary, we have our value. So our sign is 1. Our exponent is 0, 1, 1, 1, 1. There's 5 bits there. 0, 1. And then our fraction, or our mantessa, that is 23 zeros. Keep on going. So there's total there 23 zeros. That's it.